Number 7, a large company created a phone tree to contact all employees in case of an emergency. Each of the vice presidents calls 5 employees, who in turn each of each call 5 other employees, and so on. How many rounds of phone calls are needed to reach all 2,375 employees? Okay, so this is the number of employees, guys, and we start with five calls done by the vice presidents. Okay, so let's go here and let's see. So there are this many people in the company, and what you have to do is this, guys. You have to consider the round one of calls. So after those 5 vice presidents make the first round of calls, they reach 5 employees, right? They reach 5 employees that are not, look, these 5 employees that they reach, these are the vice presidents. It's 5 guys, right? I mean, it's wait. Let me. Each of the 5 vice presidents calls 5 employees, who in turn, okay, I was reading wrong. So each of these guys makes 5 calls. So this one will make 5 calls. This one. Okay, so they're gonna reach 25 people. Okay, 25 people. After the first round of calls takes place, these 5 guys will reach 25 employees that are under the supervision of these 5, right? Okay, perfect. Then each of these 25, which I'm not gonna be represented by dots, each of these 25 will make another 5 calls, and that's gonna be taken as the round 2 of calls, when each of these 25 make 5 calls on their own. So how many employees will they reach? How many employees will they reach after that second round takes place? Okay, that's gonna be 25 times 5, right? 25 times 5. It's that simple, right? And so on, right? After the round 3 of calls takes place, each of these many people will reach another 5. So basically, you're gonna have 25 times 5 times 5, and you can see, guys, the pattern here. I mean, at the beginning, five five uh 5 people at the top. I'm gonna write five. 5 are already in notice of whatever they want to do. I don't know, a meeting or something. So they already know 5, or maybe, well, no. I think we shouldn't consider these as employees. No, no, no. Only these ones. Okay, these are vice presidents. They shouldn't be considered as employees. So the first employees that getting in notice of this are these many. Okay, so if you notice, 25 can be written as 5 to the square, and then 25 times 5, that can be written as 5 to the cube, as you can see, and then this can be written as 5 to the 4, all of this, right? I'm just simplifying the description a little bit. Okay, 5 to the 2, 5 to the 3, 5 to the 4. So this sequence, guys, this is a geometric sequence, right? Because this is the first term, and I'm always multiplying by 5 times 5, and then times 5, and so on, in order to reach the next level. Okay, so basically what we need to do is this. This is the first term in this sequence, this is the second term, this is the third term, and so on. And I realize that this is a geometric series. This is the first term, and what this term means is the number of employees that are reached after the first round of calls, given by these 5 vice presidents. So this is the first term of that sequence, is this much. This is the second term, this is the third term, and so on. So if you want to put if you want to reach all employees, basically what you need to do is this. You have to sum all of these numbers, this, and this, which is this, and so on until eventually the number of employees that you reach is this many, right? So basically, how do we write the sum for a geometric sequence? You write it in this way: Sn equals u1 times 1 minus r to the n over 1 minus r. And you want the sum for some number of round calls, okay, to reach this many employees. So you get this much. Okay, u1 is 5 to the 2, which is 25, and then 1 minus r, which is 5, as we said, that's the ratio, 5 to the n over 1 minus 5. So there you go, guys. Simplify this a little bit, and then okay, let's do this. You get this 25, I'm sorry, minus 5 to the n over minus 4, and then make some other algebraic simplifications. Let me see if this thing is divisible by 25, because I'm not sure. Okay, it is. It is equal to 95. 95 equals 1 minus 5 to the n over minus 4. And then after some other algebraic manipulations, you should, if you multiply 95 times minus 4, you're going to have 380 negative equals 1 minus 5 to the n. And then we subtract 1 from both sides. So you get this. You get minus 5n. And then I'm going to continue here on with yellow. Multiply by minus in both sides. You're going to get this. Okay, and that's it, guys. That's it. At this point, you just take the calculator and go like, okay, how much is 5 to the 1? That's 5. How much is 5 to the 2? That's 25. How much is 5 to the 3? That's going to be 125 until you reach this number or you pass it. Okay, so let me check what that number would be. 6. It's actually 4, just 4. N is going to be 4. When n is 4, 5 to the n, 5 to the 4 will be 625, and you would have reached this number and actually surpass it, right? Because 5 to the 3 doesn't reach this number. Okay, so it's gotta be 5 to the 4. After 4 round calls, everybody below the vice presidents, all of these people will be put into notice of whatever thing they have on their minds. So that's how you solve problem number, well, I forgot. That's how you solve this problem.